Hi everyone. Today we are learning calculating normal force. Lesson 3, mechanics. Let's see our questions. Another 5 questions we are gonna answer today. Let's see our first question. Question 1, calculate net force, Fn, for 5 kg object. This object is not moving at rest, so we are gonna calculate normal force. Okay, please try. You know our methods. First of all, you are trying, and then you are going to see answer. We are going to explain all solution. All right, please try. Yes, it is time to check question and solution. All right. So, first of all, people, let's remember our force on this object. First of all, we have Fg. What is Fg? Gravitational force. Gravitational force, other name is what? Gravitational force, other name is weight. Gravitational force, or you can say weight. We know that. And then formula of weight is m times g. M is mass of the object, already given here 5 kg. M is 5 kg, and then g is gravitational force, gravitational acceleration. Sorry, today I don't know what's going on. Gravitational acceleration, meters per second square. So, number 1, first force is gravitational force, always this direction. And then for this object, we have normal force also opposite to gravitational force. Normal force not always up, depends on object position, people. Always perpendicular to surface. All right, start from surface. And starting point also important for each forces. So now you have 2 forces on this object. First one, gravitational force equal to weight, mass times gravity, all given here. And then we have normal force. For this question, they didn't ask, but most of questions, they're asking you draw a free body diagram. So how can we draw a free body diagram for these 2 forces? Number 1, what we said for free body diagram, first word dot, and then you can draw first force down, Fg, we have Fg, and then normal force on top, this is our F normal force. This is our free body diagram. And from now, what we know, object is not moving, so you can say F net equals 0. And how can we get F net? F normal minus Fg, or Fg minus F normal, same thing. And from now, what can we do, people? You can take with this minus Fg to this side in maths, you know, you can write F normal equals Fg. From now, we are using this information about weight. Weight equals mass times gravity. So mg we are using because F normal equals Fg, Fg equals weight, and formula of weight is mg. So 5 times 9.8. And F normal equals 49 newtons up. That's it. This is our solution for question 1. I hope everything is fine. If you have any question, you can ask me anytime. First of all, we are drawing free body diagram, and then we are writing F net. If it is 0, 0. Otherwise, you can write something else. But for now, for this question, F net is 0. And then we are writing for F net equals F normal minus Fg. Also, we can write, you can make another step. We don't need, but just in case, you can write F normal minus Fg. For F net, for this formula, people, you can use, if any object going up, you positive. Do you remember other question last lesson? We said right, positive, left, negative. Now up, positive, and down, negative. You can choose, or opposite is fine. You can choose, and then F net plus Fg. Fg is negative, so you can write like this. And then finally, you are getting 49 newtons with more details, but solution just like this, but to understand people, I'm just explaining more. This is our question 1. We have done. Now we can go to next question. Okay, let's go to question 2 now. Yes, this is our question 2. Calculate net force for 3 kg object. Same thing, people, exactly same, but now what we have 3 kg object. It was 5, now 3. Please try first, and then you should get 29,4 newtons. When you finish trying, when you get your answer, it's supposed to be 29,4. Okay, now let's explain. I'm just waiting a few seconds because you can pause video, you can stop video, and then you can carry on. You can try and you will come back. All right. Let's continue with our solution. Let's see, first of all, what we said, people. On object, you can draw forces. After that, free body diagram, step 2. Step 1, let's show our first force, gravitational force from center of object to down. We have Fg. And then normal force starts from that connection point. So just start from here, just from surface and up. This is our F normal, what we are gonna calculate. From now, what are we doing, people? We are just drawing our free body diagram. F normal up and then Fg down. If you want, you can calculate Fg first, you can get it, or directly you can write from Fn, it's up to you. So now let's write what we know, object is not moving, so F net equals 0. What was the F net? F normal minus Fg. Of course, you can use other option also, positive, negative, it's fine. So Fn minus Fg is 0. Fn equals Fg. So directly coming this side. From now, people, we know formula of Fg. Fg is gravitational force, other name is weight. We can use m times g. Now m is 3 kgs times by 9.8, and then you are getting 29,4 newtons direction already here. This is our question 2. Today, easy questions, people. We are calculating normal force. Normal force is important. Why? Because when you go to other questions, you are going to see they will ask you calculate friction force. To calculate friction force, we are going to use normal force. Friction force formula like this. Friction force equals, we are going to have constant number for each number. Do you know this coefficient number for friction? For any object, you will have different numbers. You will have it during exam, times Fn. So you are going to calculate Fn, and then you can calculate the friction if object is moving. After that, other steps will come for following lessons, you will see. But calculating F net is important. Because of that, today we focus only calculating normal force. Calculating normal force. We are focusing calculate normal force. In other lessons, we'll go to calculating friction force. And then when object moving, F net will not be 0. It's gonna move with acceleration. So you are gonna use m times a. After that, you are gonna calculate the acceleration and other things. All right. But first of all, calculating normal force. Today, in 5 questions, you are gonna see calculating normal force. This question also done. We calculate our normal force. Free body diagram. First, we are drawing. You don't have to draw free body diagram if they don't ask, but just in case we are drawing, because sometimes they're asking, draw free body diagram, and then we must get used to how can we draw free body diagram, people. If you have 2 objects, you can use 2 different free body diagrams. Okay, this is our question 2 solution. Done. Let's go to next question now. Question 3 is coming. Calculating normal force with 2 objects. Okay, getting difficult. You will see it's also easy. If you know how can we draw free body diagram, just we are going to add gravitational force Fg1, Fg2. We'll just add to get normal force on surface. But they should ask which normal force, also normal force, but just here for 2 kgs or total. Okay, normal force for total now we are calculating. Please try. It is our question 3. I'm going to wait 5 seconds to give you time to stop video. Yes, that's it. So let's continue with solution. Now, people, as you see, we have gravitational force 1, Fg1, and then Fg2. We have 2 forces because we have 2 objects. As you see, both of them coming from center of object, both of them coming from center of object, Fg1, Fg2. And then what else we have, people? F normal. So what's different from other one? Only F normal minus Fg, but now F normal minus Fg1 plus Fg2 total force, because both same direction. If you choose positive this side, other one negative, you have 2 forces on negative side. Okay, now let's go to draw our free body diagram. What we have, people, we have one object, just one dot we said we are drawing. And then first one, which one is bigger? You see 3 kgs is bigger, right? Fg1, and then you can draw Fg2, but make it straight. Please use your ruler and make it straight, not like this. And other one, next force going up, what's that? F normal. So this is our free body diagram. Freehand drawing. Okay, Fg1, Fg2, just going down, negative, and then positive. So first of all, what are we writing, people? F net equals 0. How we know that? Because objects, they are not moving. F net formula is F normal. It's already here. Okay. F normal minus Fg1 plus Fg2. So this is our equation. And from now, what can we do, people? Just all together going other side. And F normal equals Fg1 plus Fg2. F normal equals 3 times 9.8 plus 2 times 9.8, and then getting 49 newtons up. This is our normal force, calculating normal force. If I ask you calculate friction force here, how we are going to calculate, people? F friction equals nu times F normal. Done. So if they ask, you, of course, you will have this number for which object you are going to have this coefficient number, and then you are going to get friction force if they ask. This is our question 3. Let's continue with question 4. I hope you are getting it, people. If you don't understand any point, please ask me. Let's go to next question. Okay, question 4, similar to question 3 now with 2 objects. So your 5 seconds will start now to stop video, and just make sure you are trying. First of all, you should try. And 5 seconds time. Okay, now let's answer this question. Let's see how can we answer, people. First of all, what we said, you can show forces on objects. Let's draw some questions directly with solutions. Some questions I'm trying to show how can we do it all. So this is our Fg1. And next one from center of second object and straight going down. This is Fg2. From now, next one, if you draw from here, it's much better. But still same pose, it's fine. So just drawing up, what's that? F normal. First of all, we are showing on object to make sure before drawing free body diagram. Let's draw our free body diagram now. F normal going up. This is our first force. And then second one, FG1, and FG2. Gravitational force for first object, gravitational force for second object, and you can get normal force. Fn you can calculate. So from now, just I'm going quickly because you understand already. Similar question with different number. So let's see, F normal equals F net. Sorry, we are starting with F net. F net equals 0. What was the F net? F normal minus FG1 plus FG2. We are adding FG1 and FG2. Why? Because they are having same direction. They have same direction. We are just adding them. From now, people, what was the next step? Fn equals Fg1 plus Fg2. And we know Fg, gravitational force, m times m1, let's say, m1 times g plus, what's next one? M2 times g. We are calculating gravitational force for first object, gravitational force for second object. If you want, you can add m1 plus m2 times by g, or directly you can make it. So let's see, m1, what was it? 6. 6 times 9.8 plus 4 times 9.8. And then you can calculate it, 98 newtons, direction already here. Yes, 98 newtons upwards, done. This is our question 4. We have done, and then I have lesson now. I must just carry on with question 5. It is our last question for today. Now with angle. So this question with angle, so it is easy, but we have to calculate components of object. Let's see how can we calculate this question. This question, normal force, gravitational force already given, but most of questions, they don't give Fg and normal force. You should draw and show, only they will give applied force, and you have to draw the rest of them. Now mass is 5 kgs. What's our normal force? Sorry. What's our normal force? Let's see. People, first of all, we should calculate components of applied force. Component of applied force. How can we calculate component of applied force? If you have this component, just this applied force with angle, this is, first of all, just from top to a drawing dots, and from beginning, this is our F parallel. Other name is Fx also, you can say. You can use different names. And the other one, from this side till center, till beginning, till tail, this is our F perpendicular. As you see, perpendicular, same direction of F normal. When you calculate, you must just add to normal force. As you see, F normal plus F applied perpendicular minus Fg. This parallel one we don't add because object is not moving because of friction, maybe it is not moving. We are not busy with that. We are busy with only perpendicular one, only y-axis up and down. All right, we don't use parallel one. So F parallel, if maybe next time you need, how can we calculate F parallel? F applied times cos 30, and F perpendicular, how can we calculate, people? F applied times sine 30. This one you have to remember, cos and sine we are using. And then we must make formula. First of all, F net equals 0. And we can draw our free body diagram now. So first of all, you have normal force, F normal first. And then you have F perpendicular. And you have down what we have, people, Fg, gravitational force. And next one, F parallel. So from now we can write our free body diagram, and then for up and down we can write, people, we can write F net 0. We don't have to use this one if object is not moving. So F net, F normal plus F applied perpendicular, F applied perpendicular minus Fg equals 0. Okay, it's already here, you can see. From now, what can we do, people? We can take Fg this side. it is positive, and it was positive, now it's coming this side, other side is going negative. FG minus F apply perpendicular. I hope it is clear, this one. We'll have more questions about this one, people. It is just first time with angle you see, calculating components. So mg minus F apply minus sine alpha, and the m is 5, g is 9.8, and then F apply is 10, sine 30 is half. So when you calculate, you are getting F normal 44 newtons upwards. Done. So calculating what is new for you here, components of forces. All right, so we have done for today. We are going to carry on with other questions. Let's with other questions. So have a nice day, people. See you next lesson.